Okay, so we're going to talk about section 2.3, but before we talk about that, I want to remember some stuff and what type of graphs are these. Okay, so I was looking up some information and about education and things like that, and I found some graphs. So on this one, it says post-secondary, which means after high school. Enrollment rates of recent high school graduates by race and ethnicity from 1978 to 2018. So look at that for a minute. Look at that little graph, and you'll see that this color relates to Black high school students that just graduated. This one is about Hispanic, Latino high school students that just graduated, and this color is about white students that just graduated. First of all, just tell me what type of graph is it? Is it a bar graph, a stacked bar graph, a frequency histogram, an ogive scatter plot? What kind of graph is it? What do you guys think? Yeah, it is a time series graph, right? It shows us something that happens over time, how things compare over time from 1978 to 2018. My next question is kind of going to be up to you. What do you notice about this information in the graph? You could notice a lot of things. What do you wonder about this graph? A lot of things you could wonder. And then what type of graph is this one? So this one is about educational attainment, meaning how much education did they get? People that are 25 to 34 from 1940 to 2018. This color blue over the years is about what percentage of people in this age range had less than a high school diploma. They did not graduate high school. This is what percentage of people just got a high school diploma, nothing else. This is about the percentage of people who got some college or a 2-year degree, and this is about a 4-year degree or higher. And first, I just want you to tell me, what kind of graph is it? Just what kind of graph is it? Examples, it could be a bar graph, a stacked bar graph, frequency histogram, ogive, scatter plot. What type of graph is it? Yeah, these are bar graphs that have a bunch of things on each one. So this is what we call a stacked bar graph, okay? Stacked bar graph, that's what this is. Now, what do you notice about this and the information that's in this graph? There's a lot of things you could notice. You might notice that back in 1940, most people did not graduate high school. And a tiny percent of people back then would get a 4-year degree. You might notice that it's almost flipped, right? Now, 2018, closer to now, 8%, only 8% don't graduate high school. Back then, only 6% got a degree. Now it's only 8% don't graduate high school. And 64% back then didn't graduate, and how it's not quite flipped now on that end as far as degrees, but I don't know. I mean, what do you notice? There's lots of things you could notice. And what do you wonder about this? What do you wonder? I wonder a lot of things about this. I wonder why the big change. I wonder, um, is it all guys getting degrees? Is it all girls getting degrees? I wonder a lot of things about this graph. What do you wonder? Okay. Now we're going to talk about this section in the textbook 2.3. And just to give you context where we've been, here's where we are, right? We talked about graphs for 2 deals. Now we're going to talk about how to measure the pattern or a central tendency. What does the information tend to do? And this is the main idea of what we're going to be doing. Mean, median, and mode. That's old new information. But new information is, we're going to do that of a population and of a sample. Weighted mean of a data set, and describe the shape of a distribution and be able to compare the mean and median and mode for each of those. So, what the heck is this central tendency? It just means instead of looking at all the information, you're looking at what the patterns are. And a measure of central tendency is a way to give it a number that represents the general pattern. A number that represents the pattern. And the three biggest ones that are most commonly used are mean, which is really just average, median, which is the middle, and the mode, which is the one that happens the most. It's the answer you get the most. Different symbols when you talk about this little guy. It looks like an E, but it's actually a Greek letter. It's the capital Greek letter for S. We call it sigma, and all it means is you're going to add some stuff up. It's also called the summation symbol, right? Adding things up. So if you see this symbol, sum of X, it means add up all the data entries, which we call X, in your data set. Add them all up. That's what that means. So a couple other symbols. We've got this little guy and this little guy. These are two symbols that both tell you to take the average or the mean, add them up and divide by how many there are. But use this symbol when you're only talking about a sample. And what we read that as, we don't say this symbol, right? We call it bar, X bar, and it's a symbol for the mean of a sample. This little guy is another symbol for the mean, but instead of a sample, it's talking about mean of a population. And the way that we read that is we call it, it's called mu, pronounced like, mew, mew. And it's the lowercase Greek letter for the letter M. So we're using some Greek letters now. This is a Greek letter for capital S. This is a Greek letter for little m. And it's the symbol for the mean of a population. So look at these two formulas for a second. Look at these two formulas. So this guy means find the average. This guy means find the average. This guy means add up all the x's. This guy means add up all the x's. This little guy, it says N is the number of data, like this is kind of in the way, the number of data values in your sample. And this capital N is the number of data values in your population. These are the exact same formulas. It's just, are you only looking at a sample or are you looking at the whole population? That's the only difference between those two. So when it comes to mean, median, mode, how do you know which one you should use or which one is better in an instance? Sometimes there is no mode, right? Every answer could be given only once. Or sometimes there's data that has two modes called bimodal, or a bunch of different modes called multimodal. Sometimes the mean is the most important, the average, like to say the average income or the average hours worked. But it's easy to manipulate or mess with or change the mean, because if you throw in one or two extra high or extra low values called outliers, it could really significantly change the average. So sometimes that's not your best bet. Median tends to be more resistant to being messed with by an outlier. It's outlier resistant, but it doesn't take into account the specific size of your data value. So sometimes the mode is best, sometimes the mean is best, sometimes the median. So how do you know? Well, let's do an example of comparing the mean, median, and mode. And we're going to do an example where we've got students' ages in a college class. We're going to find the mean, median, and mode and look at any outliers and then decide which of those is the best way to describe the typical entry of this data. So here's our actual ages of this class. of that particular college class. All right, so look around at it for a second. If you were just going to estimate, let's see, we've got a bunch of 20s, 21s, couple 22s, 23s, 24s. Whoa, hello. Hello, 65-year-old college student, right? Coming back for more. Um, so to find the mean, right? Mean of this sample is just when you're going to add up all the entries, all these guys, and then divide by the number of entries. So you grab a calculator and you add all those up and you divide them by 20. Now you'll notice this little dot, dot, dot. That's just a symbol saying I left out some stuff, keep going. So I only wrote down 20, 20, first two here, and then the last two here, 24 and 65. But you're supposed to add up all of them in between. So you grab a calculator, you add all those up, and then you hit divide, you hit enter, and then divide by 20. Do that real quick if you haven't. When you do that, you should get around 23.8 years. So that's the average or the mean of these ages. Now the median, right, is the middle. So you're going to look at the left, there's 20 ages in here. So you're going to look at the left 10 and the right 10 and then figure out what's in the middle. Well, there's nothing in the middle there, right? So if there's no number in the middle, then you find the average of those two middle numbers, 21 and 22. So the two closest to the middle, 21 and 22, and then you add them, divide by 2. So 21 and a half years old. That is the median. And then the mode, which number shows up the most? We've got a whole bunch of 20s in here, right? So all of those 20s, that's the one that shows up the most. There are 6 of those. There's only 1, 2, 3, 4 of the 21s, 1, 2, 3 of the 22s, 1, 2, 3, 4 of the 23s, 2 of the 24s, and 165. So that one definitely shows up the most. So the mode is 20 years. Okay, so how do we decide which one of those best measures the information that we got here? Here's our mean, median, and mode. Number 2 says, are there any outliers? Okay, was there any weird age in this group? Yeah, there's a 65-year-old person in there, way older than everybody else. So number three, which measure of central tendency best describes a typical entry for this data set? Okay, well, I mean, how do we decide? Let's think through what they all say. So the mean is considering every single entry, but that 65 made this average go way up. If you did this average without that 65, I bet it would be more like 21 or 20 years old. It's a guess. The median takes everything count, but that 65 doesn't really mess with it. And the mode, there's definitely a mode, but it's the smallest number on here. So I don't really know if that's a good way to do this. So maybe let's look at the frequency chart, the histogram, and see if that helps us see what's going on any better. Okay, so they made the histogram for us. Here's the mode, right? It was 6. The median is in here. The average is over here, but then there's this big giant gap between all this. This is what's called a cluster, this cluster of information. Then there's a big gap until this weird outlier, this weird answer that stood out from the rest of it. So I would definitely say that this mean kind of got pulled over. It's almost got like it got stretched over to the right from this because of this outlier. So that's not really good. You're right. It doesn't really describe all this being way over here. This median is probably our best answer. It's kind of in the middle of this big cluster. Mode is too far to the right in this example. So I think median is definitely the best one that describes this data. All right, changing gears. Let's talk about how to find the weighted mean. Um, a weighted mean is the mean of a data set whose entries have varying weights. Like instead, kind of like dollar bills, right? You can have $15 bills, but you're hoping that some of those dollar bills are fives or 20s and not all just ones, right? So the weighted mean um, is given by this formula. So it's that symbol, which means find the average again. But this time we're going to add up whatever each data set is to how much it's weighted, and then divide it by the total weights. Okay. And an example of when you would use a weighted mean would be maybe your GPA. So let's talk some grades, shall we? So let's do an example where we find the weighted mean. Let's say last year you got three A's, three B's, and one C. Okay. And you're going to calculate your GPA for that year for those grades. Well, for GPA in general, the weights, the way that they're weighted, unless you have honors or AP classes, the weights are a little bit different for that. But if you just have regular classes, then the weights are just like this, where an A is of 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth one, and F's worth none. Okay. And you got three A's, three B's, one C, no D's or F's. So how many weights do we have, or how many grades do you have here? And what we're going to do then is we're going to multiply 4 times 3 gives us 12. 3 times 3 gives us 9. 2 times 1 gives us 2. 1 times none, right? Your 4, your 3 A's get you 12 points. Your 3 B's get you 9 points. Your 1 C gets you 2 points. All right, now we're going to add all this up, okay? There's a slight mistake there. That should be the sum of x here, the way that I did this, but that's okay. I should move that over here, but that's okay. So there are 23 points for your 7 grades. Your 7 grades. So we take your 23 points and divide it by your 7 grades. Yeah, that should be the letter X right there. My bad. I'll fix that in a little bit. Which gives you 3.28. So a 3.5 would be a middle B average, right? 3.5. A 4, of course, is an A average. Anything close to a 4 is going to be a really good average. So 3.28, that is a solid B average. That's what that is. And it makes sense. You got mostly A's and B's and a C, but that is a solid B average. Okay. So frequency distribution shapes. There's 4 common shapes. There's lots more. But when you do our histogram charts, there's some shapes that'll pop up, and we need to be able to talk about them. This one here, notice that it's almost, you know, symmetrical, like a mirror image. It's even on both sides. The mean is in the middle, the median is in the middle, and the mode is in the middle. That's what happens when it's called symmetric distribution. Okay, this shape, this pattern is called a symmetric distribution. Um, this little guy, I mean, it's symmetrical, but there's no mode, right? There's nothing that pops up higher than the rest. And because it's mostly all the same, we call that uniform distribution. It's pretty much the same thing, almost like a rectangle. This one is a rectangle, and some of them are close to the uniform distribution because they're close to a rectangle. This little guy, I mean, it certainly has a mode like this one does, right? It's got one that's a mode, but it's kind of shifted to the side a little bit. It's not smack dab in the middle like that one. And this one has a little tail, is what they call this. They call this a little tail. and that tail is on the left side where it kind of like droops down and goes off to the side. So we call this skewed left, where most of your data is over towards the right a little bit. Take a guess what this one's going to be. Hmm, big guess. It's also kind of squished to the side. It's got a tail over here, but it's on the right side. So it's called skewed right. Okay. Um, but when you're looking at those, what I want you to notice is where the mode, the mean, and the median are. So the middle of your data is over here on the left a little bit. Your mean is right here, and your mode is going to be right there. Okay. So I just want you to notice that with the symmetric, everything's in one spot. Mean, median, and mode are all in one spot. When it's skewed left, your mean is on the left side of your mode and your median. When it's skewed right, your mean, your average is on the right side. Okay. All right. So now what? Um, after you've watched this video, I might do another one where we do some examples. I want you to go in and I want you to complete section 2.3 about mean, median, and mode um, on Math Excel by this Sunday. You can do it. Assignment. Oh, if you forget how to do that, let me show you real fast. You have to go in through Clever, right? And then you're going to search for Easy Bridge. Like that guy. And then you're going to find our class, click on the little arrow on the left, and then click Math Excel for School. And here we go. So for the student version, let me pull that up. Student version, you'll notice that I've this assignment, 2.2 is due Sunday, November 8th. And I'm going to talk to you about the assignment that's 2.3 that's due November 15th. Okay, so I'm going to click on that. And I'll just do a couple of these. I'm going to pick one every other one. So we're going to start with question 1. He says, determine whether the approximate shape of the distribution is symmetric, uniform, skewed left, skewed right, or none. And then tell me why. So looking at this guy, is it what's also called bell-shaped, symmetric? Is it symmetrical? No, right? It doesn't go up in the middle and the same on both sides. Uniform would be a rectangle. This is definitely not a rectangular shape, right? It's kind of got this little slant on the right. Well, if that slant is on the right, then we call it skewed right. That little tail is on the right side. We call it skewed right. So skewed right, skewed left, symmetric, uniform, none. Skewed right. Boom. Next. I'm going to skip over a couple problems. You get the idea. You're going to do that a few times. Okay, this one. Consider a frequency distribution of scores on a 60-point test where there are a few students that scored much lower than the majority of the students. Match the distribution. Okay, so we need to, which one of these would match that information? A few students scored lower than most. Well, it looks like most people scored lower here. Let's see, a few students scored lower than most. This is all about the same. This is, I don't know, it's kind of even. So a few students scored lower than most. I think it could be B or D. Let's try B. Let's see what happens. Huh, got it right. Next. Okay, we're gonna skip ahead to a few of these. Here's one. The number of credits being taken by a sample of 13 full-time college students are listed below. Find the mean, median, and mode, if possible. If any measure cannot be found or does not represent the center of data, explain why. All right, so first we're going to find the mean. Now, you could grab a calculator and you can just add all those up and divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of these things. I'm going to use a spreadsheet. Why? Because I like them. So I'm going to open up a new spreadsheet, new tab, then hit spreadsheet there. And in my new spreadsheet, I already hit copy from that assignment. So now I'm going to hit paste, Control V, thinking, got it. Okay, now I'm going to put these two next to each other so I can see them a little bit better. So here's all my data that I just copied from here. You can always type it in, whatever you want to do. The mean. So one way to do it, add them up, divide by how many there are. I'm going to make my spreadsheet do it, right? Equals sum, because that's the word that means add them up. Highlight all these guys. And then go in there and hit divide by how many there are. And I said there were 13. So 7.23 blah, blah, blah. By the way, there is a way to do average on spreadsheets. You can just hit equals and then type average and then tell it what you want the average of. I want the average of all those numbers, then hit enter. Look at, so either tell it to add them up and then divide or just tell it to do the average. Kind of cute. So it says type an integer or, which is a whole number, or a decimal rounded to one decimal place. Okay, so I'm going to round this guy to one decimal place, which is 7.2. If you don't remember how to round, you can always cheat with the spreadsheet. Just push this button until you get down to one decimal. So cheating. I mean, using your resources, right? So 7.2. Let's check out, see if we're right. So far, so good. Okay, so now it says, does this mean represent the center of the data? I don't know. Does it look like it's in the middle of all this? Let's see. What if I just put them in order and see? Data, sort range. Is 7.2 kind of in the middle? Well, yeah, that's not too bad, right? There's a whole bunch of sixes here, and then, yeah, that's kind of in the middle. 7.2 would be somewhere around here, just kind of in the middle. So, yeah, I'll say sure. Sounds good. All right, thanks. Median, middle number, right? So we're going to count. I have 13, so I need to go, let's see, 6 this way. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6 on this side. Let me highlight that a color. And there's 6 from this side. 1, 2, 3, 4, 5, 6 from this side. Oh, so my middle number is 7. That is the median. That was easy. Does the median represent the center of the data? Yeah, it's pretty smack dab in the middle. Sure. The mode, which one happens the most? Looks like 6. This number 6 happens the most, right? So the mode here is 6. And check my answer. Hey, I'm right. And that everything else, the middle number was 7. The average was 7.2. 6 is kind of to the left a little too much. It's too small to be the middle. So I'm going to say no. The mode does not represent the center because they're not a diode. No, that's not true. The mode does not represent the center because it is the largest. Nope. The data does not have a mode. The mode does not represent because it's the smallest. Yeah, it's too small to be the middle. There we go. Easy peasy, right? You do it again. One of those another questions. Okay, now weighted average. I'm now going to show you how to use a spreadsheet to do the weighted average. So I'm going to click on here and say copy to clipboard, Control C, copy. Let's see what happens. Perfect. Control V over here. Perfect. So I got all that data and have to type it. It says the scores and their percent of the final grade for a stat student are given. What is the student's weighted mean score? So we're going to multiply the score times the weight, the percent of the final score. And because I did a formula here, let me think away. See, when I typed in a formula here, B2 times C2, B2 times C2, I can just then scroll down or fill down. You don't have to fill down. You could just do 80 times 5. It will give you 400. 93 times 5. It will give you 465, etc., etc., etc. Okay? Now I need to add up all those answers above those guys. So equals the sum, 8960. And I have to think for a second. Percent of final grade. Okay. All I want to know is how many grades did I have? So 1, 2, 3, 4, 5. There were 5 grades. So to figure out the weighted mean, I'm going to put in here the total here equals this total divided by how many answers, how many grades that we had. Well, I had 1, 2, 3, 4, 5 grades, I think. No. I divided by, my bad. I divided by the total weights. So let me do that. Sorry. Equals, add all these guys up. 100. So my weighted mean, I'm going to take this guy and divide it by this guy and 89.6. It says here, simplify your answer round to 2 decimal places. So 89.60. If we're right, ka-chow. I almost made a mistake, didn't I? So again, the way I did that, this is X times W, right? Each of these, somewhere above. This is X, this is W, this is X, W, right? All I did was multiply those two to get that one. So then this guy here is the sum of all the weights, and this guy here is the sum of all the X times the weights. And then you divide it. Okay? All right, let's do one more together. Okay, here we go. This is going to take several steps. The number of hospital beds in a sample of 20. All right, so there's 20 answers here. Construct a frequency distribution and a frequency histogram, and then describe the shape. Okay, well, we've been doing these. I'm going to add another page to this spreadsheet. See down here where it says add sheet. And I'm going to copy this data. So I click on this to copy the table, copy to clipboard, Control C, go in here, Control V, copies it in, right? So the nice thing is they tell me the classes, so I don't have to figure out the classes this time, but I do need to figure out how many are in each one. So let me write this down. Oh, yeah. So this first class here, how much does it happen? Well, let's put these in order. So data, sort range by column A. So 123 to 155. 123 to 155. There we go. And just so you guys can see where I get that answer from, I got 1, 2, 3, 4, 5, 6, 7 answers that were in that group. 156 to 188 is my next group. 156 to 188 is my next group. So 156 to 188. That's too big, so I can't use that guy. So use another color. There's 1, 2, 3, 4, 5. So far I got, oh, batteries. Things didn't die. 7, 5. And then I keep going. 189 to 221. There we go. That's 1, 2, 3, 4 of them, I believe. 220. So this could be a 4. 222 to 254. 254. That's only 2 of them. And then 255 to 287. Just 2 answers. So let me fill this in. 7, 5, 4, 2, 2. So far, so good. Plug in the computer real fast. Got it. All right, next part, construct a frequency histogram. Okay, so now I need a histogram that matches this. If you ever want to use Google Sheets to do a histogram, it's kind of cute. Somebody showed me something I didn't know. They want 1, 2, 3, 4, 5 classes. So 5 classes, insert, chart, does something. I wanted to do a histogram, and I want customize 5 classes, 5 buckets. There we go. That looks ridiculous. I don't like that at all. Ugh, I do not like that answer. That's ridiculous. Stop it. So, oh, the bucket size must be the class width. Okay, anyway. So 7, 5, 4, 2, 2. I need 7, 5, 4, 2, 2. Oh, that looks pretty good. 7, 5, 4. No, see, this is 4 right here, so that's wrong. This one doesn't start at 7, so it must be this one. It's up at 7, it's up at 5, it's up at 4, it's up at 2, 2. All right, next. Describe the shape. Is it symmetric, uniform, negatively skewed, positively skewed, or none of these? Okay, so negative and positively skewed. If you ever forget what something is and you want to look, you can always go into question help and say, view an example. And I just want to skip down until I get to the part there where they talked about positive and negatively skewed. We're just going to skip down. Yep, yep, yep. Now we got a frequency. Got it. Okay, there it is. And let's see. A frequency distribution is negatively skewed when the tail is more to the left. It's positively skewed when the tail goes to the right. Okay, so this tail goes to the right. So let's see if it's positively skewed, right? Ta-da! So right skewed is positive, left skewed is negative. And those are the ones that I wanted to do as an example with you guys. So if we go back, I'm gonna hit save my progress. So we just did 1, 2, 3, 4, 5 of the questions together out of 13. And that gives you a pretty good idea of how to do your assignment. You rock, you can do it. Oh, before I forget, if you ever go back and do an old homework, for example, let's say you're gonna go back and do this one. And you say, okay, nope, that didn't work. I'm gonna go back and do this one. It's old. See how it has an option here? Either review and practice or improve the score. Always pick this, because that way when you do the old questions, it will change your score for you. Okay, if you just do review and practice, it will not change your score. And then if you do an old one, make sure you tell me so that once you improve your score, You have to tell me that you did it so I can go back in into our school grade book and add the change there. Otherwise, if it's an old one, I won't know that you did it and I won't be looking for the old one. Okay? Okay. Goodbye.